This video is about slope. So there's some key words that we need to learn. One of them is parallel. Parallel lines are coplanar lines that do not intersect. And here's a picture of kind of a cube figure. And there are lots of parallel lines all over this thing. The symbol, two lines right next to each other means is parallel to. So I'm going to write a few statements that are true here. For example, two red lines up at the top. So the line AD, remember lines are written with a symbol above it that shows a line with an arrow on both ends. Putting this symbol here means is parallel to. And of course, if you look at the top of this box, another line that does not intersect AD and runs the same direction as it is BC. So they'll never intersect and they're on the same plane. That's what coplanar means. There are other pairs of parallel lines here. For example, AE, which is a line down the front of this cube, is parallel to BF. And there are many other pairs of parallel lines, but those are two. We need to learn the word perpendicular, which is sort of the opposite of parallel. These are coplanar lines that intersect at a perfect right angle or 90-degree angle. And the symbol perpendicular is two small perpendicular lines. So you see how those lines there make a 90-degree angle. So we're going to find a pair of lines that are on the same plane that cross each other at a 90-degree angle. For example, AD is perpendicular to. There are two lines that are perpendicular to it on this picture. Actually, more than two lines. But one of them would be AB. AD is perpendicular to AB because you can see that they're both on the same plane, like the top of this cube, and they form a 90-degree angle with each other, because that's the corner of the box. AD is also perpendicular to DC. It's also perpendicular. This is a bit of a stretch for the brain, but it's also perpendicular to a line like AE. They are also coplanar. They are on the plane that represents like the left side of this cube, right? So they are perpendicular to each other. And there are many other pairs of lines that are perpendicular here. These are just a few examples. The third option is that two lines could be skew. Skew lines are not on the same plane. They're not parallel. They never intersect. So they're not on the same plane. They sort of pass each other in space. But one of them never touches or crosses the other one. So for example, this is easier to see with an example. Let's say the line AB, which is across the top front of this box, will never cross maybe line FG. And there's no symbol that means skew. So we just have to say line AB and line FG are skew. So looking at line AB, that's at the front of this shape. It goes on forever this way. Looking at line FG, that's sort of back here, it's underneath and kind of crossing behind the line AB, and they're in completely different planes, so they're never going to cross each other. They're not parallel lines, so they're called skew. A little extension of parallel lines would be parallel planes. The two planes here that are shaded in sort of that brownish gray, those two planes are parallel, for example. And remember, planes are three letters. So, for example, plane DAB is parallel to plane HFG. I use those letters to illustrate that you don't need to use any specific three letters in any specific order to name a plane. You just use any 3 points that are on the plane. So the top plane, I could call it DAB. And there's no symbol for that above it. HFG represents the bottom plane, but I could have also used EFG or in any order GEH. But those two planes are parallel because they never intersect each other. They run the same direction as each other, and they'll never touch. Types of questions you might be asked about this in the geometry setting. So which segments are parallel to line segment AB on this picture? This line segment does not have arrows above it because it's just talking about a segment, a piece of line. Parallel to AB, we have multiple ones, and it wants us to name all of them. We have DC, runs the same direction. We have HG, runs the same direction. And we have EF, it runs the same direction. Each of these lines are coplanar with AB and will never intersect AB. Which segments are skew to line segment CD? We want to name all of the segments that are skew with CD. We'll never intersect it because they're on a different plane. So EH is one of them. and FG is one of them. So looking at those two lines, right, neither one of those will ever intersect with CD, and they're sort of similar. And another one that is skew, let's say AE, and the other one that's similar to AE on this picture, and that's BF. Those two lines are skew with CD because they're not parallel and they never intersect. Any other line that you name on this picture is either going to be parallel to CD or intersect with CD. So I want you to think about that as you look through this figure. You can pause and think about some other examples, and you'll find that any other thing you name is either going to intersect with CD or be parallel to it. All right, next question. What are two pairs of parallel planes? There are many pairs, but we only need to give two of them here. So maybe plane BAD, which is at the top, is parallel to plane FEH, which is at the bottom. Right, those two planes are parallel. And another pair might be plane ABF, which is like the left side of this box, is parallel to plane DCG, which is like the right side of this box. And again, there are other examples, but those two are sufficient. And part D, what are two segments that are parallel to plane BCFG? So they're using 4 letters for this plane, which is fine. BCFG, depending on how you're looking at this box, is sort of the back of the box. We want two segments that are parallel to that. We'll make sure that if you're giving a parallel segment, it's not one that's actually on that plane. So we're going to give two segments maybe from the front of this box, like how about segment AD? That's parallel to the back of the box, right? Because it runs the same direction. AD is parallel to that plane. Hey, AE is also parallel to that plane. It goes a different direction from AD, but both of those segments will never intersect with the plane BC GF, because both of those segments run the same direction as one segment, at least in BCGF, so they'll never intersect it. The coordinate plane, so now we're jumping into a little bit of an algebra perspective on parallel and perpendicular. The coordinate plane is a plane, right? It's a plane. It's a flat surface that extends forever in two directions. That's what a plane is. Therefore, all lines on the coordinate plane are considered coplanar lines, right? Any line that you can draw on the coordinate plane is on the same plane as any other line that you draw on the coordinate plane, because they're on the same plane. Lines that are on the same plane can either be parallel, which would look like two lines like this. You know, this line is parallel to this line, right? Two green lines that I just drew are parallel. I'm going to skip over this one for a second, because we haven't really talked about that one, but we've talked about perpendicular. Perpendicular lines would be like this one and this one. They form a 90-degree angle when they cross each other. The one I put a star next to is intersecting lines. Now, intersecting lines don't have to make a 90-degree angle with each other, right? So let's say I have a line like this. Oops. I was about to draw perpendicular lines. So I have a line like this and maybe a line like this, right? Those two lines intersect. They're not called perpendicular because they don't form a 90-degree angle, but they are intersecting lines. So on the coordinate plane, lines can either be parallel, they can be perpendicular, they can just be other intersecting lines, which is most cases, really. But lines on the coordinate plane cannot be skew with each other because they're on the same plane. And if you look back at your definition of skew lines are non-coplanar. So if I wanted to draw skew lines on the coordinate plane, one of the lines could be on the coordinate plane, but the other line would have to be off the page. And so you can't really draw that. Slope is a really important concept. In fact, it is the title of today's notes. The slope of a line is a constant, which means it's a number, right? A constant just means that it's a number that represents the line's steepness. If you look at the lines that are drawn here, the 4 lines that I drew on the coordinate plane, they're blue lines. The one on the furthest left is positive slope because the steepness of the line is going up from left to right. It rises from left to right. It's positive slope, so that it will be a positive number. For example, positive 1/2. The next one is a negative slope. It is falling as you go from left to right, and that's going to have a negative constant to represent the steepness, like, for example, -3. 0 slope would be a line that doesn't rise or fall, so there's no steepness at all, which makes sense. So 0 would be the slope. And an undefined slope would be a vertical line, which is not a function. It's not that it has a slope of 0, it's that it doesn't have a slope at all. It's an undefined slope. And so there's no way to write that other than the word undefined. So if I say, okay, what's the slope of this vertical line? You say, oh, it's undefined. Slope can be calculated by doing a ratio. So the constant that represents the slope of a line is the ratio of the line's vertical change divided by its horizontal change. Sometimes you see that written as vertical with this little triangle. That triangle is a delta, which stands for change. So vertical change over horizontal change. Sometimes that's abbreviated to rise on top and run on the bottom. The reason being, if you look at this purple line that's graphed over here, let's say I have a point right here and I have a point right here. Those are 2 points that I can easily see. The vertical change means if I wanted to go from the blue point on the left to the blue point on the right, I have to rise that many boxes, right? That's what I mean by vertical change. To go from one point to the next, how far do you have to rise or change in the vertical direction? In this case, I'm rising 4 boxes. And then how far do I have to run? Run is a sideways motion, right? We run from left to right. So I'm rising 4 and I'm running 2, which means that's my slope. And usually m is used to represent slope. My slope, the constant, is going to be a rise of 4, or a vertical change of 4, divided by a run of 2, or a horizontal change of 2. So between 2 points on this coordinate plane, I have to rise 4 and run 2. Or if you simplify that fraction, which you always should, it's rising 2 and going over 1, which you'll notice here. If I took that same blue point and I rose 2, and went over, sure enough, I end up back on the line. So rising 2 and running 1 is the same as rising 4 and running 2. So you want to reduce your slope as much as possible, which means I should go even a step further to say the slope of this line is just the number 2. It's a positive number because we're rising from left to right, and it's the vertical change divided by the horizontal change. If you don't want to graph, you can use the formula for slope instead. The formula for slope says to calculate the rise, subtract the y values, and to calculate the run, subtract the x values, which makes sense. When you find the distance between 2 y values, that's a vertical change. And when you find the distance between 2 x values, that's a horizontal change. So the change in the y's divided by the change in the x's. Just make sure you're going in the order indicated in this formula. So for example, if I wanted to calculate m for these 2 points, I take the second y value and subtract the first y value. This is y2, and I'm subtracting y1. Divided by the second x value minus the first x value. So 3 minus negative 5. Be very careful with your negatives in these slope calculations, because 3 minus negative 5 is like adding. So it's over 8. Now in this case, when we have 0 on the top, 0 divided by any number is going to be 0. So it asks us to determine if the line rises, falls, is horizontal, or is vertical. So if you go back a few slides, you'll see the notes that say positive is rising, negative is falling, a 0 slope is horizontal, and undefined is the vertical. So we have a horizontal line between these 2 points. Calculate the slope of the next 2. We're going to do the second y value minus the first over the second x value minus the first. Negative 4 divided by 8. Just be really careful with your negatives. All right, so there's my slope. It's a negative constant, simplified as much as possible, which means that this line is falling because the slope is negative. Calculate the slope for this next set of points. We're going to do the second y value minus the first, divided by the second x value minus the first. Being very careful with my double negative. The top is 5, the bottom is 5 plus 1, which is 6. That's simplified as much as possible. It's positive, which means that this is a line that rises from left to right. And I'm going to extend my page to calculate the final slope here. Negative 1 minus 6 on the top, second y value minus the first. 4 minus 4 on the bottom. When you see 0 on the bottom of a fraction, if you try to take out a calculator and actually divide it, negative 7 or anything divided by 0 will give you an error on your calculator. So to fully simplify a fraction that has 0 on the denominator, you write equals undefined. And then, of course, that means that this line is a vertical line. Vertical lines are those ones that slope is non-existent. It is undefined. Lines are parallel and perpendicular. So this is what we talked about in the context of geometry, right, when you were looking at that three-dimensional cube-like figure. On the coordinate plane, you can see parallel lines by calculating their slopes And if their slopes turn out to be the same, so this one rises 4 and runs 2, that's the same as this line. It rises 4 and it runs 2. So they end up having the same exact steepness, and therefore they can never catch each other. They'll never intersect with each other. So what do we know about parallel lines on the coordinate plane? Same slope. Perpendicular lines have the exact opposite reciprocal slope. So opposite, that means positive, becomes negative. Reciprocal means A over B becomes B over A. It means flip it upside down. So if you wanted to calculate these two purple lines here, we have a slope of positive 4 over 2 for one of them, which we know is positive 2 over 1, or just plain 2. Looking at the other line goes, let's say to get from this point to this point, the other line goes down 2 and then over 4. So that means we have a rise of negative 2, because instead of rising, right, we're falling. And then we're still running to the right. We always run to the right by 4. So this simplifies to negative 1 over 2. So if you look at the relationship between these two slopes, one of them is positive and one of them is negative. The first one is 2 over 1, and the second one is 1 over 2. So two lines that are perpendicular have opposite reciprocal slopes of each other, which is what this little formula shows here. So you may be asked to tell whether the two lines written here are parallel lines, perpendicular lines, or neither, and you don't necessarily want to graph them in order to figure it out. So we can use our slope calculation to figure it out. Let's find the slope of M1, or the slope of line 1, by doing the second y value minus the first over the second x value minus the first. Notice it was minus negative 2, so I'm just going to write this plus 2. This is negative 3 over 2. Let's find M2 with the slope of the second line. Second y value minus the first, and since it was minus the negative 1, I'm writing it as plus. Second x value minus the first. Again, it was minus a negative, so I'm writing it as plus. 3 plus 1 is 4, and 2 plus 4 is 6, and this simplifies to 2/3. So looking at these two slopes here, are they parallel lines, perpendicular lines, or neither? So first of all, they're not the same slope, and parallel lines we just learned have the same slope. Check if they're opposite reciprocal. So one of them is 3 over 2, the other one is 2 over 3. So the reciprocal thing works. One of them is negative, the other one's positive. So the opposite thing works. So if these two lines are opposite reciprocals, that means that they are perpendicular lines. And if you just got two slopes that weren't in any way related to each other, right, they weren't opposite reciprocals of each other, and they weren't the same, then you would be talking about neither. And that is all.